150 knots means underwater, the physics wall. Here's the part that keeps engineers awake. Water punishes speed. Push a hull past a few dozen knots and drag climbs like a cliff. Around 30 to 50 knots, pressure drops along sharp edges and spinning blades. The water flashes into vapor, cavitation. It chews metal, screams acoustically, and leaves a frothing signature any hydrophone would hear from miles away. That's the wall. Everyone knows it. To go faster, you need to change the rules. The known trick is supercavitation. Wrap the craft in a bubble of gas so it flies through vapor, not water. The Russian Shkval torpedo is the poster child, rocket-driven, blunt nose, a cavitator disc up front to shed water and inflate a pocket of gas. Best public numbers put it roughly in the 180 to 200 knot range, straight-line sprint, poor turning, deafening noise, and a hot, turbulent wake. It's fast, but you pay for it with control and stealth. Now stack that against the track in our plot room. 550 knots, underwater, with hard turns inside its own wake and a dead stop on command. No roar, no plume, no thermal bloom. If it was supercavitating, we should have seen a multi-sensor tantrum. Heat from rocket exhaust or gas generators. Bubbles shimmering up like a boil. Acoustic thunder from gas collapsing behind it. Instead, quiet ocean, clean scope, pressure signature without the mess. An engineer we spoke with did the napkin math. At that speed, even a fist-sized object would be dumping absurd energy into the medium. The heat load alone should leave a ribbon of warmer water, slicing the thermocline like a zipper. The bubble collapse behind a supercavitating body creates shock fronts, bangs and rattles that sonar operators know in their bones. None of that showed. He circled the only honest conclusion. Either the object wasn't pushing the water the way we do, or our assumptions about what it was interacting with were wrong. Let's get concrete about the wall. Drag in water scales brutally with velocity, double speed, and you're not doubling resistance, you're multiplying it. Traditional propellers cavitate long before triple-digit knots. Pump jets mitigate, but they're still chewing the ocean. Supercavitation breaks the contact by surrounding the body in vapor, but steering is a nightmare because control surfaces have nothing solid to bite. You can vector thrust, tweak bubble geometry, or bleed gas asymmetrically, but high G turns inside a small radius? Not with known control authority. Not at 550 knots. Then there's pressure. At modest depths, ambient pressure is already measured in atmospheres. Any bubble you ride has to be sustained energetically against collapse. That costs power. Power makes heat. Heat makes signatures you can't hide if you're doing it chemically or electrically in a human-built way. Our sensors didn't find them. The ocean was stubbornly normal. So the fork in the road looks like this. Option 1. Sensor stack failure across independent systems. Radar, passive acoustics, perhaps even EO/IR windows, correlating a phantom that behaves consistently. That would imply a systemic problem with national implications, because those sensors aren't boutique, they're fleet-wide. Option 2. A propulsion or field interaction regime that reduces effective drag without vaporizing the medium, and that either masks or bypasses the usual energy bookkeeping we rely on to catch fast movers. People toss around terms like magneto-hydrodynamics and field reduction, as if they're levers you can pull off the shelf. MHD has been tested. It's quiet at low speeds and terrible at producing thrust at scale in seawater without insane power and heat signatures. Field reduction, the idea of manipulating spacetime or local inertia, lives at the edge of theory and rumor. If something can alter how water feels around a body, reducing viscosity or decoupling inertia, then the cavitation wall stops being a wall. But we don't have a lab report for that. We have tracks that behave as if someone does. Engineers look for the dirty fingerprints, vortices, harmonics, turbulence cascades, thermal scars, bubble curtains. None showed. The petty officer's console told one story. The ocean refused its usual footnotes. That mismatch is the tell. If the medium isn't screaming and the craft is still sprinting, either the medium has been tamed locally, or the interaction has been shifted somewhere our instruments don't look. Here's the stakes talk everyone in the briefing room hears. If it's real, our tech gap isn't a step, it's a canyon. Every doctrine built on acoustic superiority, on speed versus stealth trade-offs, on torpedo kinematics, starts to wobble. If it's a sensor artifact, then our surveillance net has a hole big enough for a carrier group to sail through, and that's a different kind of nightmare. What nobody in that room could shake was the maneuver package. Speed is one claim, control is another. Stops, right-angle cuts, shelf-tracing climbs, all without the ocean's normal protest. That's where the physics wall becomes a mental one. The numbers don't just overshoot our gear, they insult our map of what water allows. If the physics don't fit, you don't throw away the night. You go looking for more nights, more rooms, more signatures that rhyme. Because a single track can be an error. A pattern is a briefing. And this wouldn't be the only time the ocean stayed quiet when it shouldn't have. The catalog, decades of Navy USO incidents. One night can be a glitch. A decade of them turns into a catalog. Quiet briefings start with a map and a handful of pins, then the pins grow teeth. The pattern stretches from the Catalina Channel off Southern California, down past Puerto Rico's abyssal trench, out across the North Atlantic and up into Arctic training boxes where the ice cracks like old paint. Different crews, different platforms, the same impossible speed, the same surgical indifference to water. The Catalina thread goes back to the Cold War. Surface ships logging fast movers that outran any torpedo solution. Submarines hearing pressure signatures pacing them, then sliding ahead like a thought. The targets would pop in near the islands, trace the shelf break, then either climb toward the surface without breaking it or dive over the lip of the continental drop like a base jumper taking a breath. In the 1980s, a destroyer team tracked one for 7 minutes. The plot looked like a zigzag cut with a steel ruler, too sharp for anything with a propeller. Puerto Rico carries its own stories. The trench there is an elevator to blackness. 3 crews flying ASW patterns logged sonobuoys going quiet excited. That odd combination of no noise and clear presence, right before a fast pressure change streaked down the gradient. A reserve pilot, years later, told a friend about a white object like a capsule, entering the water with no splash, no foam, as if the surface had been peeled open for it. He said it almost as an apology, then shut the door on the subject. Cold water doesn't make it sane. In the Arctic, under ice where mistakes last longer, submarine crews reported runners that crossed their baffles and slid off their quarter with no blade count and no cavitation bloom. The term wasn't in any manual. It was the word they used when the ocean felt haunted. During a NATO exercise, a fast mover paced a line of boats near a choke point, threading between hulls like it understood lane discipline. The formal write-up called it unresolved anomalous contact. The watchstanders called it something else. Microstories give the catalog a pulse. A young sonar operator rotated off a boat after 3 deployments, told his brother he'd had enough of chasing ghosts, and switched to a shore billet before he left the service entirely. Another story comes from a Hello Crew chief who swore he watched a pale shape slide under their hover at night. No phosphorescent trail, no disturbed foam, just a clean absence moving purposefully. He waited until retirement to say it out loud. Parallel threads kept the pattern from becoming a campfire tale. Submarines reported shadowing by silent fast movers during certification runs. The contacts maintained standoff as if they were observing training profiles, then departed at angles that made sonar plots look like glitches until they repeated. Enough to be routine. Surface groups experienced seam cuts, mirror-still lines on the ocean that traveled against wind and swell, followed by contacts erupting from the surface into air and vanishing on airborne radar. Those reports would land in a stack already primed by rumors of Transmedium craft, and nobody laughed anymore. Complications crept in around human activity. Incidents spiked near training ranges, San Clemente, AUTEC, northern edge areas, places wired with hydrophones and wrapped in patrol arcs. They also concentrated along undersea telecom cables and power interconnects, corridors of infrastructure humming with electricity and information. A cable team logged an unexplained attenuation followed by a restored signal after a fast mover track crossed the line. No fishing damage, no quake, just a bruise that healed itself too neatly. The catalog grew teeth in internal memos. Language shifted from if to how often and what parameters recur. Analysts noted the same signatures: sharp angle course changes without a speed trade, dead stop holds, silent acceleration, and disappearances near bathymetric features. The memos stopped trying to weigh belief. They counted behaviors. One-line surfaces again and again. No acoustic or thermal correlates commensurate with observed kinematics. That sentence is what anxiety looks like in a briefing. A pilot added a strand that threaded back to Catalina. He'd run intercepts on drone swarms near the Channel Islands. Lights in formation, small, fast, persistent. On one of those nights, the swarm hugged the surface and a seam appeared, a knife cut in moonlight. The lights dove into it, and the seam closed like nothing had happened. "We thought someone was spoofing us," he said. "Then we realized spoofing is a capability, not a conclusion." Across all this, duty logs show a pattern of vanishing ink. Entries scrubbed down to weather. After-action summaries that jumped from initial detection to secure channel debrief. FOIA responses came back with the shape of a story hidden under black rectangles. The absence wasn't random, it mapped to the hotspots. Meanwhile, a fisherman in Avalon kept a careful notebook. Years later, his granddaughter matched his notes by accident with publicly known Navy range dates. Nights of lights under the water moving like schools but straight, lined up with exercises. He hadn't known where the Navy trained. He just knew when the sea felt busy. By the time these incidents earned their own briefing slide, they weren't a curiosity. They were workload, pattern analysis requests, extra sonobuoys, tasking for P8s to sweep not just sky and sea, but the seam between them. Crews cracked cautious jokes about company in the hallways of the ocean, and then went quiet when a new track appeared that put the joke back in its case. The catalog doesn't argue. It accumulates. It points to a shape moving along our coasts and trenches, attentive to our ranges and cables, present in our training lanes, and indifferent to the physics that hold our boats together. Meanwhile, one hotspot kept returning to the briefings, a corridor where pins on the map stacked like a countdown. The Catalina Corridor, America's USO alley. You can draw the corridor with a fingertip. From Point Conception down past Santa Barbara, threading between San Nicolas, Santa Barbara Island, San Clemente, and Catalina, then sliding off the shelf into water that turns from blue to black. Major shipping lanes cross here. Carrier groups cycle through. The Navy's range complex laces the water with sensors. If anything strange is going to show up, this is where it has an audience that can measure it. The old stories start in the 1950s, when radar vans on the bluffs and destroyers off the islands logged fast movers under the surface, tracking close to the shelf break. The language was different then. Unusual submarine behavior, probable interference, but the plot lines match. An object appears near Anacapa, skates along the 200-meter contour like it's keyed to the bathymetry, then darts south toward San Clemente's range waters, where it either vanishes or rides the seam near the surface, refusing to break it. One night in the 1970s left a scar on a sonar operator's voice. He was riding a frigate east of Santa Cruz Island, listening to the ocean's metronomes, shrimp crackle, distant screw beats, when a smooth, pressure-heavy presence slid into his band. No blade rate, no machinery thrum. It paced the ship's course for 3 minutes, then pivoted in place and ran perpendicular, crossing their bow in seconds. He watched the bearings swing like a gate. The log reads like any other. Times, bearings, ranges, terse notes. He told his roommate later, it moved like a pen line. The corridor collects micro-stories that rhyme. A Catalina harbor patrolman swore he saw pale geometry under a glasscom surface one August night, rectangular and steady, moving without ripples toward the channel. A helicopter crew out of North Island held a high hover during a range evolution and watched a seam cut the moon's reflection from stern to bow, as if someone were dragging a knife across the water. A yacht captain, ex-Navy, radioed a submerged obstacle moving at high speed off Avalon, then withdrew his report when the schedule officer called him back and suggested he'd seen a pod of dolphins. Local lives overlap Navy dates in ways no one planned. A fisherman working out of 2 harbors kept meticulous logs on current and bite patterns, the way old-timers do because the ocean will cheat you if you let it. On 4 separate nights, he wrote the same line, lights underwater, straight, fast, no break. Years later, his granddaughter compared his notebooks to published range announcements. The nights matched major exercises. He'd never heard of AUTEC or San Clemente's box numbers. He just wrote what he saw. By the 1990s, pattern language crept into briefings. Catalina wasn't an outlier, it was a lane. Contacts appeared at the northern end, near the channel's pinch, then moved south along the shelf, staging in the lee of the islands before sprints toward deep water. Meanwhile, shore stations logged surface seams moving against wind and swell, narrow bands where the water's skin looked wrong. Sometimes those seams ended in splash events, only there was no splash. The surface displaced, then smoothed, and the track continued below. Multiple platforms started to stack their agreement. Sonar stations ashore caught pressure signatures without the expected acoustic teeth. P3 and later P8 flights dropped sonobuoys in grids, listening for prop signatures and hearing instead a presence, a moving null, a displacement without roar. Surface search radar painted transient skin returns skimming at the boundary. Electro-optical cameras rolled and recorded flat sea with a line cut through it, traveling too fast to be a tide line, too straight to be wind. Complications emerged in clusters. Incidents spiked on nights when drone activity harassed surface groups near the islands. The swarms hugged the water, and seam cuts appeared beneath them like rails. Another spike coincided with maintenance windows on undersea cables threading from the mainland to island facilities. A team fixing a repeater recorded an unexplained attenuation, followed by clean signal as a fast track crossed the cable line. No trawl marks, no anchor drag. The bruise healed without explanation. Inside the range office, a quiet designation took shape. Not a public label, nothing a reporter could FOIA. Just a shorthand in tasking notes. Persistent anomaly area. It meant extra buoys on certain nights, additional eyes on the seam between mediums, and a heads up on the net when ships transited the pinch points between island shadows. Crews stopped rolling their eyes. They started drawing bigger boxes on their mental maps. A micro-moment stuck with a P8 senior chief. He drank his coffee cold because a seam appeared beneath their orbit. The surface looked like muscle under skin, tension moving. The buoys didn't squeal. They went clean and taut, like a string plucked outside hearing. The analyst in back marked the event no correlate, and saved the file to a compartment that lived outside normal traffic. The Catalina Corridor isn't a monster tale. It's a route with rhythm. Entries near the northern islands. Shelf tracing runs at speeds that make doctrine stumble. Surface seams that act like doors. Departures over the continental lip toward deep water. The Navy doesn't publish this, the ocean does. And in internal spaces where language gets careful, the maps around Catalina grow more ink. The ocean hides things. Here, sometimes they leave clean lines on the page. The Tic-Tac connection, seam cuts and splash events. The first time aircrew started saying seam, it sounded like slang. After the Nimitz flights in 2004, it became a marker. Pilots described a line on the Pacific, a strip where the surface looked stitched tight. Commander Fravre's intercept didn't begin in the sky. It began with a disturbance at the water, a churning patch and a shape beneath it that refused to pick a domain. Controllers saw a primary vanish, then another appear low, accelerate, and step out of the radar's expectations. From the cockpit, the white capsule, call it Tic-Tac if you like, didn't behave like any aircraft. No wings, no exhaust. It cut angles that made stomachs float. The part that unsettled everyone came seconds earlier, the watermark. A seam that moved against swell, holding its crisp line while the object either rose from it or played station over it. It was like the ocean had a hatch, one aircrew said later, then asked not to be quoted. Back in the ready room, the debrief felt split screen. Tapes pulled, recorders collected for higher level analysis. On the scope review, a low contact merged with the surface seam. Then the airborne track executed a climb that chewed through altitude markers in a blink. The pilot's narrative said emerging. The paperwork said maneuvering near a surface disturbance. Both were technically true. One told a bigger story. Meanwhile, in the radar van, operators watched the low-altitude return skate, just above sea clutter, without ever showing the wing rock wobble you'd get in ground effect. It didn't hug the air, it ignored it. When it accelerated, the Doppler spike looked like a smear, not a ramp. The van chief made a note he'd never written before. Splash without splash. He meant a splash event minus the physics. No plume, no spray, just a displacement that closed clean. This is where the seam language bled into Catalina. Crews working the corridor started logging seam cuts, followed by airborne UAP tracks, and, later that night, underwater fast movers racing the shelf. 1P. 3 crew reported a seam crossing beneath them as a separate track leaped skyward and then winked off. The buoys didn't hear masts or rotors. They heard quiet pressure moving like a firm hand under canvas. The link wasn't a theory slide. It was a habit in the data. Surface seams, then splash events that lacked splashes, then either an object ascending to the sky or diving to the trench. Pilots who'd never thought about oceans began to redraw their mental maps. "We watch the sky," a WSO said. "Turns out we need to watch the water's skin." He rubbed his temples and added softly, "And what's under it?" Complications came fast. When investigators asked for the full recorder packages from flights with seam events, some sets arrived with missing frames. Not wiped, corrupted, like a hiccup swallowed the seconds when an emergence occurred. The official narrative hardened around unidentified airborne, while the crews started a quiet file labeled Transmedium. In that folder, you'd find the Catalina seams, the Puerto Rico entries with no splash, and the Nimitz patch of boiling water that calmed too quickly. One aircrew microstory. A pilot flying chase on a training hop saw a long scar pulling across the sea, sharp and unnatural. He nosed down for a closer look. The scar stopped, as if it noticed him, and became ordinary water. A minute later, a white cylinder streaked up his 9 o'clock and disappeared. He didn't radio it. He waited until the ground, then said it out loud once. The intel officer's pen hovered, then resumed on a different line. Radar technicians talk about seam ghosts with a grudging respect. You get a track that rides the side lobes, then firms up into a target that shouldn't be that clean at sea level. EO rolls and captures an immaculate horizon, except for one ruler-straight defect sliding upwind. Seconds later, the airborne track breaks out. The term splash event gets used for both directions, down into the seam, up out of it, without the signature splash. It's bureaucratic language for a door opening without hinges. In briefings, the Transmedium hypothesis stopped sounding like science fiction and started sounding like a checkbox. Sky isn't the only domain, one briefer said, and nobody laughed. The questions shifted. If an object can move the seam, what's moving it? If it can exit the water without tearing it, what's it doing to the medium? There were no confident answers, only a narrowing of possibilities that all felt outside our playbook. Data recorders kept getting pulled. Narratives diverged, pilots spoke in straight lines, paperwork curved around terms that wouldn't survive a FOIA. Still, the seams kept cutting, the splashless splashes kept marking transitions, and crews who'd never shared a story started finishing each other's sentences. The link wasn't a rumor, it was a rhythm, and every time a seam appeared, someone in CIC reached for a second.